Where am I?
Where indeed? Where indeed? Would you believe outside our solar system?
Outside the solar system?
Yes, on a small asteroid, some 5 miles in diameter. Behold!
That's impossible!
The Sun and the 9 planets. Well, 8 planets. Pluto, after recent discoveries of many objects similar to it in composition and mass, was demoted to the newly created status of dwarf planet in 2006, a rank it shares with 4 other celestial bodies. But I digress, as we scientists often do.
Amazing, but hey, I know you, you're...
Oh, pardon me, sorry, but I'm always mistaken for him.
Huh. But I could swear...
Oh, I'm sorry, Mr. Tompkins. Just a little private joke at your expense. Yes, you are quite right. I am Professor Albert Einstein, but you may call me Al.
How do you know my name?
I was a friend of your father, George Gamow, physicist, cosmologist, and author of the Mr. Tompkins book series.
Book series?
Yes, Joe, as we called him, also developed the Big Bang theory of the origin of the universe. We worked together on several projects. Why, I even met your brother Professor Igor when he was only 4. He just wanted to be a cowboy. How amusing that such a famous scientist as George Gamow would have a cowboy son. What is the matter?
I'm not a real person? Just made up?
Yes, lad, you're only a fictional character, but follow Dr. Einstein's advice and you will be fine. So tell me, have you any questions about Professor Igor's lecture?
I once saw a movie about a black hole. If gravity's the weakest of the universe's 4 forces, how can a black hole's gravity be so strong that not even light can escape it? Are there 2 types of gravity, like the strong and weak forces inside the atom?
No, Mr. Tompkins, there is only one gravity, but the strength of the gravity is directly proportional to the mass divided by the volume of the object, which we call density. Watch closely, my boy, as I pluck Earth from its orbit, like so. Squish it down to the size and volume of a cherry, just incredibly increasing its density, then shrink it to the size of an ant. Finally, place you on the surface of the cherry. Try as you may, you cannot move even 1 step due to the huge gravitational force of the cherry.
Okay. Already I get your analogy. I understand your point. Let's see if I can extrapolate from what you've told me, Al. If I inflated the Earth until it was the size of, let's say, Jupiter, I could jump 100 feet in the air since there's so little mass in so large a volume.
Yes, Herr Tompkins, you have the idea, but we would have to use Newton's laws of motion to calculate exactly how high you could jump. But now time to play with our Mr. Sun. Let's make 3 suns, shall we? Then tightly compress them until they are the size and volume of the Earth, again enormously increasing the density, and Achtung, a black hole. Its gravity is so great that nothing can escape it, not even light. Well, almost nothing. Stephen Hawking proposed that due to a quantum fluctuation, a temporary change in the amount of energy in a point in space, a little matter can seep out of a black hole. As a result, the black hole shrinks. The decreasing volume of the black hole increases the radiation seepage, thus speeding up the evaporation of the black hole until it eventually disappears. The radiation has been named, surprise, surprise, Hawking radiation. I must admit that in my day I thought the idea of a black hole was absurd, but never let it be said that Einstein is stuck in his ways.
Perish the thought. Another question, if I may, Al.
Of course, but hurry, you may wake soon.
I have down in my lecture notes, let's see, here it is. With the masses and speeds we have in the solar system, Your theory of relativity and Newton's laws of motion are pretty identical. It's only when we deal with huge objects at speeds nearing the speed of light that your theory becomes important?
No, Herr Tompkins, that is entirely untrue. Your notes are simply wrong. Newton believed that gravity forces traveled instantaneously from point A to point B. I, however, have clearly shown that nothing can go faster than light speed. For example, Newton believed if the Earth suddenly moved 1,000 miles closer to our Moon, it would alter its orbit instantaneously. Einstein predicted a significant delay before the Moon altered its orbit. On a larger scale, if the Sun were suddenly to disappear, Newton would predict that the planets would immediately fly off into space at the exact moment the Sun vanished.
Could the Sun suddenly disappear? 1 minute it's here, the next it's gone?
No, it couldn't, but for the sake of our Gedankenexperiment, let us say it did. Since gravity waves travel at the same speed as light, 186,000 miles per second, it would thus take 8 minutes before we on Earth would see the Sun blink out. 8 minutes until darkness enveloped the Earth. 8 minutes until Earth careened off into space.
If Earth left orbit, would people float off as if in the Vomit Comet?
No, Earth's gravity for all practical purposes is independent of the Sun's gravitational pull. We would, however, notice the stars in new, unfamiliar positions. The solar system's planets and moons would be invisible to us without sunlight reflecting off of them. Photosynthesis would cease and there would be no oxygen to breathe. Within days or weeks, the Earth would soon grow too cold to sustain life.
Okay, Al, okay, I understand. I have a hard time sleeping at night as it is. So, just what exactly is gravity?
Gravity is really just curved space-time around objects. More massive the objects, greater the curvature. Larger the curvature, greater the strength of gravity. Watch your step, son, don't fall. Who knows where black holes lead?
So that's the basic idea of general relativity, eh? Space is curved?
Yeah, and this model of gravity has yet to be proven wrong by today's physicists. Though there are perhaps a few things here and there that may need to be added to resolve certain issues.
You know, Al, I think the first time I read about general relativity was in a science magazine. It said that each scientific concept would have been discovered eventually, even if its historical founder hadn't done so, with one notable exception: 1915's general relativity, also known as new gravity.
Well, that is certainly possible, but we will most likely never know.
You must be a wizard to have discovered it. Just conjured up the magic equation out of nothing. Poof!
You flatter me, Mr. Tompkins, and I do rather like this look on me. But no, I just thought a lot. It all started with a Gedankenexperiment, my most famous one, incidentally. This daydream of a 16-year-old boy eventually led me to propose the special theory of relativity. If I could catch a light beam and put a saddle on it, I'd travel at the speed of light. Or not. I wonder, at that speed, will I see my reflection in a mirror? Well, do I see my reflection? Look out!
No more, my head is spinning! Oh. Now I know how the dollar felt when the dot-com bubble burst.